Here is a more interesting spherical coordinates integration question, a little bit more interesting, a little bit more involved than our previous examples here. Integrate f of x, y, z is the square root of x squared plus y squared plus z squared over the region x squared plus y squared plus z squared is less than or equal to 4, z is greater than or equal to 1, x is greater than or equal to 0. So let's fill in the easy things right away, and we know we're going to be switching to spherical coordinates. The integrand is rho. This right here is showing us rho squared is less than or equal to 4, or rho is less than or equal to 2. In the for theta bounds, well, let me start filling in theta and phi and rho here. For theta bounds, the only thing that's happening in the xy plane is we have, well, we're inside a circle of radius 2. We know that. Projection of this into the xy plane is circle of radius 2. X is non-negative. So we're in the right half of the circle in the xy plane. This shows us that theta runs from negative pi over 2 to pi over 2. Okay, z is greater than or equal to 1. This should feel familiar. There's a little bit of overlap to a problem we did before, but I think it's a very important problem, so going to reiterate it. So the idea here is, okay, so we have our sphere. It looks like this, radius 2, and then we cut it. Then we cut it at z is equal to 1 here. So we're integrating over the spherical cap right here. So to figure out our phi bounds, what is this? Here is the phi angles that we have to worry about. Phi, the smallest can be a 0. The biggest it can be, well, this point right here has z is equal to 1. It also has rho is equal to 2. But we know from our spherical coordinates conversion chart that is somewhere in my pile of papers. I don't see it, but I'll just write down the answer. Z is equal to rho cosine phi. So this tells us z is 1, rho is 2. So 1 is equal to 2 cosine phi. Phi is equal to, cosine phi is equal to 1/2. And so this corresponds to phi is equal to pi over 3 radians. And then as for our rho bounds, we need to pick up that chunk of rho here. The biggest rho can be is 2. The smallest rho can be corresponds to the plane z is equal to 1. But again, z is rho cosine phi. So 1 is equal to rho cosine phi. Rho is equal to 1 over cosine phi. Okay, so this is going to be, so this is all of our setup that we need to do. So let's go to new slide here with this information now. Theta runs from negative pi over 2 to pi over 2. Phi runs from 0 to pi over 3. Rho runs from 1 over cosine phi to 2. And then we are integrating rho squared, we're integrating, the integrand is rho times rho squared sine phi d rho d phi d theta. Okay, so what is going on here we are integrating, looks like rho cubed. Antiderivative of rho cubed will be rho to the 4th over 4 times sine phi. Plug in rho from is equal to 1 over cosine phi to 2. At some point I should realize that this d theta, the theta integral can just be factored out. So we have this times the integral phi runs from 0 to pi over 3 of, so it's going to be 2 raised to the 4th is 16 divided by 4 is 4 sine phi times, plug in 1 over cosine phi, or it's not times, minus, this is going to be sine phi over 4 cosine phi to the 4th. This integral is just pi. Then we have, let's see here, this first, we can break this into two separate integrals. So this one, the antiderivative sine theta is negative cosine, oh sorry, not sine theta, sine phi. Negative cosine phi, plug in phi from 0 to pi over 3. Minus, so for the second integral, what we're going to do, so sine phi upstairs, cosine phi to the 4th downstairs. I think this calls for substitution. U is equal to cosine phi. du is equal to negative sine phi d phi. So this is du, like that. So let's see here. We end up with 1/4 times u to the negative 4th power du. When phi is 0, cosine phi is, sorry, yeah, when phi is 0, u is cosine 0 is, oops, not 0, 1. When phi is pi over 3, cosine pi over 3 is 1/2. Okay, so pi times, let's see here, negative cosine of pi over 3 is negative 1/2 plus cosine of 0 is 1 plus, okay, what do we have here? This will be negative 1/12, u to the negative 3rd power, plug in u from 1 to 1/2. Pi times, that's 1/2, minus 1/12 times 1/8 minus 1. So, assuming I didn't make any mistakes, which is, possible in this long of a calculation, that's how to do this. Again, when we're doing these kinds of spherical integration problems, I mean, they're almost necessarily a bit messy. There's no, when you're doing a triple integral and you're doing it all the way through, they're going to be messy here. So let's not lose sight of the main interesting thing here. Probably the trickiest part of this whole problem is coming up with the phi bounds and the rho bounds. So make sure you're able to do this.